All right, this is my second video of the day. So I'm going to take a second and go through these solutions to the worksheet that I assigned on Wednesday. So let me open it up here. This is what we're looking at. So the same thing we were doing last class, right? We just want to draw all of the forces that are acting on our object. So I'm going to take a second, move this a little bit. Never mind. It's not going to move. There we go. All right. So I can draw a little bit. So it's the same kind of thing that we were doing last class, right? We just want to look at, okay, where are my contact points and what forces could I have from those contact points, right? And then we always have our one non-contact force, which is gravity. So I'm going to draw gravity in right away. F, G. We could call it a box, or I forget what we were calling it. I'm going to call it a box. So B for box. So my object is this box. So B for box. Gravity is caused by the Earth. So I'll put a little E for Earth on there. All right. And then I look for contact points, right? And I have a contact point right here. And I actually have two things contacting there. And they're contacting along ropes or strings, it looks like. So I'm going to have two forces there. I'm going to have a force going up this way because of one of the strings, and a force going up this way because of the other string. So I actually have two tension forces there, right? They're tension forces because they're acting along ropes or strings. So I'm going to say Ft for tension force on the box caused by, I don't know, string 1, right? So we'll call that string 1. And then over here, I have another tension force on the box because of string 2. Actually, I probably should have switched the 1 and 2, but whatever, right? And then we have S standing for string. Right, and there we go. That's my one non-contact force along with my two contact forces. All right, next one. Always going to have gravity. So I'm going to put gravity on there on the box because of the Earth. And then this one actually is my first case where I have two contact points. I have a contact point here because of that string and a contact point here because of this string. All right, and each one of those is contacting because of a string. So it will be tension forces again. So here I'll have a tension force on the box because of, we'll call that one string 1. And here I'll also have a tension force going this way, right, on the box because of string 2. You'll notice that the tension forces always go away from the object along the line of the string, right? So this one went up away from the box along the string, to the right on the box away from the string, right? Up to the right away from the box along the string, up to the left away from the box on the string. Object motionless. Again, we always draw gravity in. That's our first one. It's the easy one because of the Earth. And then I could turn this into a little ramp here, just so we have something to call that. So I'm going to make this a ramp. And let's look for contact points, right? Again, I have two contact points. I have this contact point with the ramp, and I have this contact point with the string. So let's start with the string. String, it's a tension force. It goes away from the box along the line of the string. So that'll be a tension force on the box because of the string. I have contact here because of a normal force, right? They're just touching. So I'm also going to have a normal force on the box because of the ramp, right? And then we have R for ramp. All right, nothing crazy. We don't have friction in this one, because the box doesn't want to move because it's held up by the tension force, right? So we don't need another friction force there. We just have the tension force. All right, number 10, right? Drawing gravity right away. There's gravity. And then we again have two contact points. We have a contact point on the bottom right here because of the, we'll make it a ramp again. And we have a contact point here because of the wall. So we have two contact points again. Are they friction? No, they're not moving. That box isn't going to want to move. It's being supported there. Are they tension? No, there's no ropes or strings. So they have to be normal forces. So we get a normal force going up and to the right because of the wall, right? The wall is supporting it up this way. So that's going to be a normal force on the box because of the wall. I'll put W for wall up here. And then the ramp is supporting it from the bottom up this way. So we get a normal force on the box because of the ramp, right? I can also label the wall here to let me know, right? This is a wall. And there we go. We've got our two contact points and our non-contact, right? That's all that we need. If we look here, next one, right? Gravity right away, F, G, B, E. Our object is being pulled by a string to the right. So we have a couple contact points. We have a contact point there with the string and a contact point here with the ground. So we'll get a tension force because of the string to the right. So this will be FTBS, right? Tension force on the box because of the string. And then on the ground here, we'll have first a normal force, right? FN, B, well, we need a name for this. I've been turning these into tables. So I'll put some legs on it and make it a table. All right, so we'll put in a lowercase t for table. All right. And because it doesn't say, right, that there's no friction and our box is definitely either moving or wanting to move to the right because we're pulling on it, we will also have a friction force to the left, right? Friction always goes opposite the direction of motion. So we'll have an FF for friction force on the box because of the table. All right. And the last two are a little bit tricky, but not tricky at the same time. Right, we can obviously put in gravity on the box because of the earth. And then when I look for contact points, there's nothing else touching our box. And because all of our other forces are contact forces, we're stuck. There aren't any other forces here. We can't label anything besides gravity. Gravity is the only one. And then if we go down here, a ball rising in the air, we put in our non-contact force, gravity, FGBE. This time, B is standing for ball instead of box. But then I look for what is it touching, right? There's no air resistance, so it's not touching air. There's nothing else there for it to touch. We're done, right? Gravity is the only non-contact force. If we're gonna put another force there, something has to be touching it, and there's nothing else touching it. So that's all we got, right? We've just got gravity. All right, so there is the solutions worked out for this one. I will also be posting a saved file of this so you guys can just look at the answers if you want to there. All right, stop share, stop the recording. Good work, guys.